All right, so the last one that I'm going to do from 15b is question 17. Yep, good. Here it is. And partly because it's in red, partly because it's another one where we're not given an actual x value to work with. They just say a. So if we come up with an equation for a tangent, it will be in this general type of form, where if you plugged in a value for a, you could get your equation. Although before we start, it says sketch a graph of this function. You might know, I've written it down, you might know what something like this looks like, y equals 1 on x. Right, hopefully you know. You've done rectangular hyperbole before. Right. However, if this was squared, right, this x was squared, then you can no longer get negative y values, right? Because when you square negative numbers, you get positive values. So this part here would look fairly similar, right? And as your x's get bigger and bigger, you've got 1 divided by a bigger and bigger number. Your y's are going to get smaller and smaller over here. So they're approaching 0, but from above. But what about for negative x values? So if I'm looking down here, where as x approaches minus infinity, or very small numbers, I'll have very small numbers squared, and they will end up being positive values, and as those x values get closer and closer to minus infinity, this whole denominator here will get larger and larger and larger. It'll be 1 minus a very big number, which will give me a very small number. And I'll get this shape like that, which I've drawn terribly, I'm sorry. Okay, so the y will approach 0, but it will approach from above again, right? Because you can't have negative values. That's supposed to look symmetrical. It's just sketching, right? And the general shape will be the same with this 8 on the top. I mean, you could set up a little table of values if you like. Maybe we have -2, -1, 0, 1, 2. So we could say, all right, if x equals -2, we'd have 8 divided 4, which is 2. If x equals -1, 8 on 1 is 8. If x equals 0, we're undefined, right? So we cannot have that. And look, my pen is quite difficult to use, so this is going to be a very rough sketch. You can probably do a better one in your book. If you put a 1 in, you get an 8. If you put a 2 in, you'll get a 2. Right, symmetrical on either side. So at x equals -1, the y was 8, maybe up here somewhere. When x equaled -2, the y was 2, and it had that shape. And just maybe remind yourself of what the rectangular hyperbola looked like. Right? It will never reach 0. Right? We've got this vertical asymptote of x equals 0. Right? So that is an asymptote. We've also got a horizontal asymptote of y equals 0. So that's your horizontal asymptote. Not very good at saying asymptote. I could maybe plot a couple of points. When x equals 1, I'm saying the y equals 8. When x equals 2, the y was 2. And there you go. So a sketch can be pretty rough and ready like mine, although you really should, if you're sketching, point out the asymptotes. Okay, so write those down. Okay, so there's your sketch. Now, we wanted an equation of a tangent, so we'll need a point and we'll need a gradient. The point would be 8 on a squared. Sorry, why am I doing that? That's the y value. We do the x value first. It will be a. All right, the y value for the point will be 8 on a squared. To get the gradient, I need the derivative. And I haven't left much room here, but it will help if I write this in an index form to see it a bit easier. So it'll be minus 16 x to the minus 3. So that will be minus 16 on x cubed. The derivative at point A will be minus 16 on a cubed. Right. So there's my gradient, right, for any x value of a. So to come up with the equation for the line, for the tangent, right, which I should really write down, I'm trying to rush through this a bit. So you should lay your work out properly. We should say equation of tangent, right, is simply just coming from the gradient expression. So it's minus 16 on a cubed. That's our gradient at a equals the change in y minus 8 on a squared over the change in x. So giving myself a bit of room, I'm going to go up here. What do we end up with? Y minus 8 on a squared equals minus 16 on a cubed times x minus a, and I'm going to put it into a y equals mxc type form, so we'd have minus 16 on a cubed x, we'd have plus 16 on a squared, right, so a times minus 16 will be minus 16a, and we'll get some cancelling out there to leave an a squared. Then we'll have to add this to both sides. We'll have plus 8 on a squared. So the equation of the tangent, right, and no matter what your a is, you could put it into this formula and you would find the equation of a tangent that would fit with this curve up here, right? So it's a pretty cool little question, right? Now, I feel like I've done that bit, but I haven't read ahead, and I'm going to see what the question's asking me to do. And I can't read that, so well, that's my emails. Don't read my emails. Okay. What do we got? If the tangent cuts the x-axis at A and the y-axis at B, find the coordinates of A and B. Oh, internet's a bit slow. Let's read that again. If the tangent in B cuts the x-axis at A and the y-axis at B, find the coordinates of A and B. Right, okay. Cuts the x-axis at A. So what does it mean to cut an x-axis? Right, an x-intercept. Right, so we have an x-intercept at point A. Right. So this tangent equation, right, I want to know where's its x-intercept. Okay. Well, its x-intercept is when the y equals 0. Right? Okay, so we need to think about minus 16 on a cubed x plus 24 on a squared. Where does that equal 0? It will be at point A. Okay, so let's think about this. I'm going to have to go up here. I'm going to run out of room for this question. We could say 24 on a squared has to equal 16 on a cubed. So what I've done there is, what have I done now? I've added, oh, and I need the x. I've added minus 16 on a cubed x to both sides, right? Let's multiply both sides by a cubed. We'd have 24a cubed on a squared equals 16x. Right, so I've moved that over, multiplied by a cubed to get rid of this divide by a cubed. Take this side times by a cubed. That way I can cancel this out. And I could say x would have to equal this. Right, so x equals, if we divide these by 8, we get 3 on 2a, right? Now, where can I write that? I might make a note of that up the top. So point A was where the y was 0 and the x was 3 on 2a. Now, what if I got room to find b? B is the y-intercept, right? Now this one will be easier to see. So the y-intercept was at point B, and that happens when the x value equals 0. If the x value equals 0, that whole thing becomes 0, and I'm just left with 24 on a squared. So it's like, therefore, the y would equal 24 on a squared, and I could say point B would be x is 0, y is 24 on a squared. Okay, so that's one is a bit easier. Now I'm going to make a bit of room here. Just thinking, what do I need for the next part? Hopefully I'm not going to erase too much. Let's find out. We found coordinates A and B. Find the area of triangle OAB and discuss the area of the triangle as A tends towards infinity. Now, I'm just thinking to myself, do we know if the A value is positive? I don't think we do. We know the area of a triangle would have to be positive. Let me just read. Find the area of triangle OAB. I'm gonna draw a picture where I assume that the A is positive. So we sketched the graph to start, but if we just look in the first quadrant, right, we've got our curve coming sort of down like this, right? we've got our tangent at point A. Where could I draw it? Maybe like through here. Oh, this is going to be rough. Whoa. Okay, that was pretty bad. I'm sorry about that. Now the y value there was 24 on a squared. The x value there is 3 on 2a. And clearly this is not drawn to scale. And me using this pen, yeah, okay. That's supposed to be tangential, so that should be, that tangent line there should be touching this curve. Anywho, you can see a triangle OAB. So point A was this one, right? That's point A in here. This is point B. So we've got this triangle, right? Let me even draw. Here's the triangle is there. B, A, and O, which is the origin, right? So the area of a triangle, is half times the base length times the height. All right, so I need to think about height. What's the height of my triangle here? It's easy to work out because I'm starting at 0. So I'm going from 0 up to 24 on a squared. So therefore 24 on a squared is the height. Right? What's the base length of the triangle? Well, it goes from 0 to 3 on 2a. So that would be the length. Right, so because the triangle goes from the origin, it's easy to work out its dimensions in terms of height and base length, right? Now the area will be half of that base length. So 3 on 2, what's half of 3 on 2? Half of 1 1/2 is 3/4. It'll be 3/4 a times 24 on a squared. And those a's will cancel. So we will get 4 will cancel with that. We'll get 6. They will cancel as well. So we'll have 3 on, I'm trying to do too much at once. Let's just deal with the a's first. 3/4 times 24 on a. Right. Now we'll cancel the 24 and the 4. So I'll be left with a 6 here. So I'll have 18 on A as my area. Now that A value can't be negative. I can't have a negative area, right? So it's like note areas are always positive. Area is positive. One way I could express that is to say I need the absolute value of A. So using these modulus symbols, I could say that A needs to be a positive number, because what I could have done is I could have thought about a tangent for an A value that was negative. I would have been over here in quadrant 2 and drawing the triangle that way. But the area of that triangle would have still been a positive. Number. Sorry, I just dropped my book. And I think that's as much as we can do. We're not given any numbers at any point. Let's just check the question again. See what it says, because I've forgotten. 17. Find the area, discuss the area. So finding the area, we just have to leave it as 18 divide A. right? Because it depends what A is. A could move. Right? It's some X value, but now this last bit I didn't do. Discuss the area of the triangle as A approaches infinity. Oh, okay. Well, the picture would be nice here. I might need to redraw it. If A approaches infinity, so I might actually try and redraw this again. I'm just looking at quadrant 1, thinking about a positive A value. We've got our curve, something like that. We've got our triangle. It's supposed to be tangential. No, that's just too bad. Let's try that again. All right. Okay, we had this point here. Now, if this is 3 on 2A, but if the A value gets really big, then this point here is going to move that way, right? And this point here is going to be coming down. It's going to be getting smaller and smaller and smaller, moving that way, right? So eventually you're going to end up with a triangle that's not a triangle, it's a flat line, right? So that you can imagine this triangle kind of stretching out that way, but also coming down here, and you won't have any area, right? So and I can see it in the equation, right? So I could say as A gets really big, 18 divided by some huge number like 1 million, I'd have 18 millionths. Area is going to get very small. So as A approaches infinity, the area approaches 0, right? And I can see it in the equation, right? I'd have 18 on some huge number. But I can also think about it from the diagram, because the triangle would eventually end up flat and be at some point where it's no longer a triangle, I guess, and it's just a straight line with no area, or area equals 0. All right, so that one was interesting. Hope you enjoyed that.